Welcome back to The Deep Dive, the show where we extract the absolute best, most astonishing information from the frontiers of science and translate it into knowledge you can use. I'm your host.
And I'm your expert.
And today, we are strapping on our snowshoes and hiking deep into the fungal kingdom for a truly special mission. This is our Wonder Fungi special.
Indeed. We're moving past the hype and really focusing on the hard neuroscience.
Yeah.
Our mission today is to understand, at the level of molecules and network dynamics, exactly how psilocybin is achieving this.
Yeah.
This sustained therapeutic relief in severe mental health disorders.
It's incredible. We're talking about fundamentally rewriting the brain's pathways.
We really are.
And the single concept driving all of this profound change is neuroplasticity. I mean, you just think about that for a moment. We're looking at why a single supervised therapeutic session can lead to sustained improvement in conditions that traditional daily medications taken for years often just fail to touch.
The key isn't dosage frequency. That's the old model.
Yeah.
The key is biological flexibility.
So where do we start? What's the problem we're trying to solve here?
Well, precisely. We have to start by defining the biological problem, which is, at its core, rigidity.
Rigidity.
Conditions like treatment-resistant depression, severe anxiety, even OCD, they're fundamentally characterized by rigid, repetitive, negative thought patterns. The patient's internal world is just stuck in a loop.
A loop of rumination, self-blame, entrenched fear.
Exactly. It's a prison of thought.
Okay, let's unpack this using the analogy we promised. This is really the core analogy that helps visualize this internal rigidity and, what the fungi actually accomplish.
The sledding hill.
The sledding hill. So imagine your brain is this magnificent winter sledding hill covered in snow. When you are mentally healthy, the snow is soft, it's fresh, and your sled, which is your consciousness or your thoughts, it can choose any path down the hill. You can adapt to changing conditions.
But the act of thinking, a negative, repetitive thought, let's say it's excessive rumination about a past failure, or just a constant loop of self-criticism.
We've all been there.
Oh, absolutely. Well, that's like taking your sled down the exact same path, over and over, day after day, year after year, and especially when stress or depression intensifies, that path doesn't just stay soft.
It compacts. It carves out these deep frozen ruts. And these ruts, they're the pathological patterns of thought. They're the neural shortcuts that become overwhelmingly dominant.
So your sled, your subjective experience, your ability to steer.
Yeah, your free will almost.
It's now forced down the exact same negative, self-blaming, rigid path every single time. It's almost impossible to turn. It's impossible to find a new perspective because the rut is just too deep, too hard, and too frozen.
And that structural and functional rigidity, that's not just a metaphor, is it?
Not at all. It represents actual patterns of hyperconnectivity and even, as we'll see, structural degradation in the brain.
So this is where our deep dive explores the wonder fungi solution. Psilocybin acts as this profound disruptor that introduces a massive, temporary, fresh coat of powder snow.
A complete whiteout.
Total reset.
And that fresh powder, it temporarily covers those deep frozen ruts. It smooths the entire landscape, dissolving the rigidity and creating this critical window of extreme flexibility.
And that gives the patient the neurobiological power to, for maybe the first time in years, steer their sled.
To find novel vantage points, to carve an entirely new, healthier trail. And the science that explains how it performs this feat is, well, it's truly remarkable.
Okay, so to truly appreciate the scale of this disruption, this snowfall that psilocybin causes, we have to first deeply understand the area it targets, the source of those frozen ruts. Let's start with the network responsible for defining who we are, the default mode network, or DMN.
The DMN is, well, it's the anchor of our subjective reality. It's an intrinsic network of interconnected brain regions that becomes highly active when we're not focused on the external world.
So when we're daydreaming,
when we're resting, when we're mind-wandering, when we're forming future plans or engaging in intense self-reflection, it's absolutely crucial for our sense of consciousness, our ability to project ourselves across time, and our internal narrative, our concept of the self.
So if DMN is kind of the headquarters for our internal monologue, where does it physically live in the brain? Let's trace those key components.
Its structures span across the cortex and deep into subcortical regions. Key among them is the prefrontal cortex, or PSC.
Okay.
Especially the medial PFC, which handles executive functions, decision-making, and integrating emotion. Then you have the posterior cingulate cortex, or PCC.
The PCC.
And that's widely considered the hub of the DMN. It's central to integrating information about the self and personal history.
So the PFC and the PCC are the major players in that self-referential loop. But what about the areas that are injecting the emotional content and the memories into that loop?
Well, that's crucial. We have to include subcortical areas like the hippocampus, the HC, which handles declarative and self-referential memory, the content of who you were and what you did.
The raw data of your life story.
Exactly. And the amygdala, which is the center for processing emotional valence, particularly negative inputs like fear and distress. When these four areas, PFC, PCC, hippocampus, and amygdala, are pathologically linked, you have the architecture of depression.
Wow. So if those structures are the landscape, what defines the frozen rut pathology in a patient who's experiencing severe depression?
The pathology is defined by two related problems: rigidity and overactivity.
Okay.
In patients with treatment-resistant depression, longitudinal research consistently shows there is increased baseline activity and, more critically, increased functional connectivity within the DMN.
Functional connectivity. You mean they're talking to each other too much?
Or too efficiently, at least. Imagine the connections between these regions becoming like superhighways, but they're only carrying negative traffic.
So that hyperconnectivity is the physical manifestation of rumination, right? The system is just feeding itself. I'm imagining the sled running over the same spot so many times that the ice beneath the snow is rock solid.
That's exactly the biological reality of the rut. The network is essentially locked into a highly efficient, yet dysfunctional, conversation. This loop becomes so dominant that it suppresses the activity of other networks,
Like what?
like those associated with external awareness or creative problem solving. It's always running in the background, even when the person is trying to focus on a task.
Let's focus on the PFC for a second, the region for executive function. It should be helping regulate negative input, shouldn't it? But in the depressed brain, it seems to be doing the exact opposite.
It's acting as an integrator, but a dysfunctional one. We see PFC hyperactivity acting as a central processing unit that receives and then amplifies negative input.
Amplifies.
Yes. It's getting high-volume, negative emotional data from a hyperactive amygdala, which generates the excessive negative feeling. And simultaneously, this tight link disturbs the retrieval and context of those crucial self-referential memories stored in the hippocampus, often biasing them toward negative interpretations.
So instead of the PFC being the regulatory boss that says, okay, calm down, this isn't that bad, it's acting as the chief alarmist, making everything worse.
Precisely. And this chronic dysfunction, this neural overutilization of the negative pathway, it's not benign. It causes measurable structural damage over time.
What kind of damage?
Research consistently links depression to marked atrophy.
Atrophy.
Meaning neuronal loss, a significant reduction in the density of synapses, particularly in the prefrontal cortex and the hippocampus.
Wait, let's just pause on that. That's a staggering point.
Right.
The deep frozen ruts aren't just pathways. They represent areas where the terrain itself has eroded or degraded.
Yes,
The brain is physically being degraded by chronic, unrelenting negative cycles.
it is. The constant stress, the lack of neurotrophic support that usually promotes healthy connections, it leads to this structural decay. And this is why standard talk therapy or cognitive behavioral therapy often struggles to break these severe patterns.
Because the machinery is broken.
The physiological machinery needed for flexibility of the soft snow is gone. The PFC has literally lost its necessary synapses.
That makes the therapeutic goal incredibly clear. We can't just talk the patient out of the rut. We need a biological mechanism that first softens the ruts.
And then helps rebuild the eroded landscape.
That is the core hypothesis of psilocybin treatment, isn't it?
Absolutely. The goal is twofold. First, a rapid, powerful disruption and desynchronization of these pathological, tightly connected DMN patterns. And second, the subsequent promotion of structural growth to repair the atrophy and allow for new, healthier connections to form.
Which brings us to the agent of disruption. How does a single molecule derived from a mushroom achieve such a massive, fundamental, and targeted reset of the brain's deepest networks?
It's just elegant molecular mimicry. Psilocybin itself is what we call a prodrug.
A prodrug, meaning it's not the active ingredient itself.
Not initially. Chemically, it's 4-phosphoryloxy-DMT. Once it enters the bloodstream, the body's enzymes, particularly one called alkaline phosphatase, they rapidly strip away that phosphate group,
Okay.
and this metabolic step converts it into its active form, psilocin, or 4-hydroxy-DMT. Psilocin is a molecule that crosses the blood-brain barrier and mediates all the downstream psychoactive effects.
And its chemical structure is the key to its action.
Absolutely. Psilocybin structure is almost identical to our body's key neuromodulator, serotonin.
5-HT2.
Exactly, 5-hydroxytryptamine. This structural similarity means that psilocybin acts as a very effective impersonator, targeting the serotonin receptor system.
But it doesn't just hit all serotonin receptors, right? If it did, the effects would likely be far more widespread and, well, less therapeutic.
That's right.
So which specific receptor is the crucial switch for that fresh powder snow?
The essential switch that mediates the profound functional changes in consciousness alteration is the 5-HT2A receptor, the 5-HT2AR.
Okay.
Psilocybin functions as a partial agonist predominantly at this subtype. We know this with a high degree of certainty because if you pre-administer an antagonist like ketanserin, a compound that blocks that receptor, you completely abolish the acute psychoactive effects.
The whole trip just doesn't happen.
The perception changes, the sense of ego dissolution, gone.
So we know the key. Now we need to know where the lock is. Where are these crucial 5-HT2AR locks concentrated?
They are highly, highly concentrated in the neocortex, particularly within the deep layers of the prefrontal cortex, specifically layer V pyramidal neurons and the association cortices.
So they're right at the heart of the DMM.
Right at the functional core. When
Right.
psilocybin binds, it engages these receptors, which are G-protein-coupled receptors or GPCRs. They trigger a signaling cascade that leads to an increase in intracellular calcium, which is essentially the signal for a massive, immediate change in activity.
That sounds like the initial blast, the moment the fresh snow starts falling heavily on the landscape. But here's where it gets complicated, right? This is the major scientific complexity, the point that researchers spent years debating. We have studies that suggest both increased and decreased activity in the PFC following psilocybin. So what is this excitatory-inhibitory conundrum?
This is the physics of the snowfall, and it's critical for understanding the chaos that precedes the change. The 5-HT2A receptors are present on two functionally opposed types of cells in the cortex.
Two types.
The glutamatergic pyramidal neurons, PYR, which are the main excitatory projection cells,
The go signal.
and the GABAergic interneurons, IN, which are the main inhibitory regulatory cells.
The stop signal.
Exactly. So activating the same receptor type can send two entirely different competing signals.
How does that work?
On one hand, psilocybin activates 5-HT2AR on the excitatory PYR neurons and on the thalamocortical afferents that feed into them. This causes a massive immediate release of glutamate, the main excitatory neurotransmitter.
And that's the sensory flooding, the altered perception.
Exactly. The initial chaotic experience. This is the source of the hyperfrontality argument.
So that would support the idea of a highly activated, highly chaotic PFC.
It would. But on the other hand, psilocybin also stimulates 5-HT2AR on those inhibitory GABAergic interneurons, causing them to release GABA, the brain's main inhibitory neurotransmitter.
So it's hitting the brakes.
It's a powerful brake. It's a compensatory mechanism trying to calm down the overexcited pyramidal neurons. The brain is simultaneously flooring the accelerator and slamming on the brakes.
That must make measurement incredibly difficult. I mean, if you're trying to measure the net effect, how do you determine which force, excitation, or inhibition is winning at any given moment?
That difficulty is why the initial research resulted in such conflicting conclusions between the two leading groups.
The Zurich group and the London group.
Right. The Zurich group, relying heavily on PET imaging, which measures metabolic activity over longer time windows, and some relative fMRI, they found evidence of increased PFC activity. They called it hyperfrontality.
And they linked this directly to the peak subjective experience.
Yes, to ego dissolution. But the London group, focusing on functional connectivity with fMRI, which has better temporal resolution, they saw the opposite, didn't they?
They did. They detected a profound deactivation and decoupling throughout the default mode network. They saw a reduction in connectivity between the PFC and the PCC.
And they suggested their findings were more indicative of the temporary dissolution of the rigid self-structure.
Yeah.
They even speculated that the Zurich group's metabolic findings might be an artifact of the measurement itself.
Wait a minute. So if one group says the PFC is hyperactive and the other says it's decoupled and deactivated, how do we reconcile this? Is it possible that the drug just breaks the measurement system because the activity is just too complex?
That's a very insightful point, and it's exactly where the scientific consensus has moved. The key insight is that focusing solely on the net change in activity, is it up or is it down, is missing the forest for the trees. Regardless of the net effect, the functional outcome is undeniable. The system goes into massive temporary disruption.
The functional outcome being the fresh coat of powder snow.
Exactly. Researchers now prioritize the concept of brain entropy. The activation causes a massive disruption of functional connectivity, a measured desynchronization that is more than 3 times greater than that produced by powerful stimulant medications.
3 times greater.
This effect temporarily causes the brain to fall apart in its usual rhythm, significantly increasing brain entropy, which is a measure of the variety of accessible neural states.
So the sled doesn't just slow down or speed up, it loses the structure of the track completely. The increase in entropy means the brain is highly flexible and accessing states it hasn't used in years.
It creates a state of functional anarchy, an overwhelming information flow, which is precisely the neural mechanism of the fresh coat of powder snow. The rigidity is momentarily obliterated, and the patient experiences a profound softening of habitual cognitive structures. This allows the system to reset before the structural changes even begin.
So we've established the acute disruption, the fresh snow that wipes the slate clean. But that snow melts quickly, so we need to move from that temporary functional flexibility to lasting structural change.
Right.
How does that initial molecular blast translate into a permanently flatter landscape that supports new, healthier navigation?
This is where we transition into the repair phase, true neuroplasticity, the building of the new trails.
Okay.
That initial massive excitation, driven by psilocin hitting the 5-HT2AR, it triggers an immediate and robust cascade in the excitatory pathways. This quickly accelerates the activation of key glutamate receptors, specifically AMPA and NMDA receptors.
And glutamate is the fundamental workhorse for excitatory signaling, so if we push its activation, we're basically signaling a high-energy demand that requires the brain to reorganize itself. What does that chemical signal stimulate internally?
It flips the grow switch inside the neurons. This signaling cascade leads to a massive rapid increase in the production of Brain-Derived Neurotrophic Factor, BDNF.
BDNF. I've heard this called the miracle grow for neurons.
That's a great way to put it. It's essential for neuron survival, growth, and differentiation. And simultaneously, this activity strongly activates the TRKB-mTOR signaling pathway.
Okay, let's spend a moment on the TRKB-mTOR pathway. That sounds highly technical, but you called it a master regulator. Why is this pathway so vital for long-term therapeutic change?
It's the command center for cellular growth and maintenance. The TRKB portion refers to the receptor for BDNF. So when BDNF binds to TRKB, it activates the downstream cascade, and a crucial element in this chain is mTOR,
mTOR.
mammalian target of rapamycin. It's an enzyme complex that is a master regulator of cell metabolism, growth, and proliferation.
So the cascade starts with the psilocin binding that leads to BDNF being produced, which then plugs into the TRKB receptor, which activates mTOR. What is mTOR specifically instructed to do?
mTOR is told to massively ramp up protein synthesis. This is the material needed to rebuild the degraded structure of the depressed brain. It promotes neurogenesis, the formation of new neurons, although that's less prominent in adults, and far more importantly for our discussion, synaptic plasticity.
Strengthening, forming, and reforming those communication points.
Exactly. Psilocybin enhances plasticity by directly engaging this profound structural overhaul.
So the body is given the growth material and the explicit instructions. What's the physical evidence of this growth? What are the carving materials the brain is creating for the new trails?
We see rapid and persistent structural change in the form of spinogenesis and dendritogenesis.
Okay, help us define those two terms for clarity.
Spinogenesis is the growth of dendritic spines. Imagine a dendrite, the arm of a neuron, as a telephone line. The spines are the little receiver dishes sticking out, forming the postsynaptic contacts.
But the communication junctions.
Literally.
Yeah.
And dendritogenesis is the increased complexity of the dendritic arbor itself, the entire branching structure of the neuron. More branches and more receiver dishes means exponentially greater communication capacity.
That's the physical rewiring in action. Can we quantify the structural change, especially in those regions we said were degraded, like the medial PFC?
The data here is, well, it's truly stunning. Preclinical studies show that a single dose of psilocybin caused approximately a 10-fold increase in spine density and size in the medial prefrontal cortex of mice.
Tenfold.
Yeah.
We need to put that into context. That is not a small incremental change we see with a typical SSRI, which works over weeks or months to stabilize existing connections.
Not at all.
How quickly does this growth happen and how long does it last?
The initial growth is rapid, initiated within hours of administration. And crucially, this growth is persistent. It was still measurable and robust 7 days later, and while it diminished over time, researchers could still detect the significant presence of these newly formed spines 34 days after that single dose.
34 days later.
And this sustained growth is linked to a corresponding reduction in stress-induced depressive behaviors in the animal models.
So, while depression causes atrophy and rigidity, psilocybin promotes a sudden burst of scaffolding, reversing that neuronal loss and synapse reduction. The new spines and connections are the newly paved, healthier paths in the fresh snow. It's giving the patient biological permission to adopt cognitive flexibility and a new perspective that lasts well beyond the acute trip. It's a literal physical renewal.
Absolutely. The structural foundation for the new life paths is laid down, and the brain has regained the synaptic connectivity and excitatory neurotransmission capacity it had lost to chronic stress and depression.
Okay, so now that we've established the molecular action and the physical growth, the most vital aspect of the therapy is next. How does this profound neuroplasticity translate into sustained recovery for the patient? I mean, the fresh snow is only temporary.
Exactly. This moves us into the functional results of the disruption, what the brain is capable of doing in the days and weeks that follow.
Right. What does this state of high entropy, this soft, flexible slope, actually allow the brain to achieve functionally?
The experience results in a massive desynchronization of those tightly locked brain networks. This leads to greater functional complexity and neural signal diversity. The tightly integrated DMN, the source of rigid rumination, temporarily loses its habitual grip,
And this allows novel connections to form.
linking regions of the brain that normally don't speak to each other, leading to profound new insights.
And this ties directly into the Rebus hypothesis, right? Relaxed beliefs under psychedelics. This is a crucial functional explanation.
It is. The Rebus hypothesis posits that our consciousness is largely shaped by predictive coding, or established prior beliefs, the neural pathways that have been reinforced over years.
The ruts.
The ruts. And these beliefs are normally maintained by strong top-down inhibition originating in the prefrontal cortex.
So the PFC in a normal state is the ultimate editor, filtering incoming information to fit the existing narrative. In a depressed state, that narrative is just rigidly negative.
Exactly. When psilocybin temporarily relaxes that top-down inhibition, it enhances bottom-up information flow, especially from emotion and memory-related regions like the hippocampus and amygdala.
So the editor is taking a nap.
The editor is on vacation. This allows novel, unfiltered emotional breakthroughs and insights to emerge from deeper parts of the psyche, unconstrained by the old, negative narrative.
So the rigidity melts. The patient suddenly realizes, wait, that narrative I've held for 10 years isn't fact, it's just a pattern. That temporary flexibility is the window of opportunity we keep stressing.
It is the golden period. We see this functionally as DMN decoupling. Psilocybin strongly reduces functional connectivity between the PFC and PCC, effectively breaking that self-referential rumination pattern. This window of neuroplasticity is initiated within hours and can persist for days to weeks. The system is pliable.
Okay, this brings us to the critical safety nuance. We have to stress this because the molecule is only half the equation. Psilocybin provides the structural and functional potential, the fresh powder snow, but that snow is not permanent.
Absolutely. This is the most important clinical distinction. We must emphasize this reality. The drug is only the snow, not the skier.
Say that again?
The drug is the snow, not the skier. The increased neuroplasticity is profoundly experience-dependent. It means the new connections are created, but they are fragile. They need to be used and reinforced immediately.
So if the patient, the skier, is left alone without guidance, what happens?
If they don't actively do the work of integration and therapy during this time to carve the new trails, the underlying biological reality takes over. The fresh snow melts.
And the brain reverts.
The brain's natural tendency, aided by established behavioral patterns and environmental triggers, will revert to the rigid, negative circuits. The old, deep, frozen ruts will regain their dominance, leading to potential relapse. The new connections simply wither because they weren't utilized.
That is the physiological necessity of integration. It's not just a post-session debrief, it's the directed behavioral reinforcement required to capitalize on the neuroplastic window. What does this look like in a real clinical setting?
Therapeutic support is mandatory. It encompasses preparation, setting intentions, and building trust before administration. It includes guided support during the experience. But the heavy lifting occurs in the weeks after, during the integration phase.
And that's to help the patient process the often overwhelming and insightful contents of the experience.
Yes, and to help them carve the new trail. They need to translate the profound cognitive and emotional breakthroughs into concrete, lasting behavioral change.
Can you give an example?
Sure. If a patient suddenly realizes they can forgive themselves for a past mistake, the integration work involves developing practices, journaling, mindfulness, somatic practices to apply that insight and reinforce the new self-compassionate neural pathway every single day.
So therapist is essentially a guide, helping the skier choose a direction and then teaching them how to maintain their speed and form so the new trail is carved deep and permanently into the snow.
It's exactly, ensuring it remains dominant even when the temporary neuroplasticity fades. The brain needs direction to channel the new structural capabilities into adaptive, positive pathways. Without this intentional guidance, those increased spine densities might not be functionally organized into a cohesive, positive network. The success of the treatment relies entirely on the successful partnership between the molecule and the mind.
The necessity of integration clarifies why this is a therapeutic model, not just a pharmaceutical one. But now we have to look at the results. Does all this molecular rewiring and functional flexibility actually deliver the sustained help that patients with treatment-resistant depression desperately need? What are the breakthrough clinical efficacy rates?
The clinical outcomes, particularly from the major trials over the last 5 years, are, well, they're exceptional, and they're challenging our entire concept of psychopharmacology. Psilocybin, when paired with supportive psychotherapy, has demonstrated both rapid and sustained symptom relief in major depressive disorder, or MDD.
Give us the hard data on that long-term relief. We need to be specific about the durability.
The follow-up data is remarkable. In one landmark study focusing on patients with NTD, participants received just 2 doses of psilocybin with supportive therapy. At the 12-month follow-up,
A year later,
75% of participants maintained a significant clinical response, and astonishingly, 58% achieved complete remission.
remission, meaning they no longer met the clinical criteria for depression.
Correct.
58% remission after only 2 administrations spread over a year. I mean, that is a monumental figure that completely changes the calculus of treatment. How does that compare specifically to the current standard of care?
It contrasts sharply. Standard treatments like SSRIs, such as escitalopram, they require daily administration indefinitely, and they often carry significant side effects. Sexual dysfunction, weight gain, emotional blunting, which often lead to noncompliance. In a phase 2 trial comparing psilocybin to escitalopram, both treatments reduced depressive symptoms at 6 weeks. However, psilocybin achieved this with far fewer administrations, and the secondary outcomes, measures of well-being, emotional regulation, general functioning, actually favored the psilocybin group.
So not only is it working faster and requiring far less frequent administration, but it also seems to be promoting a higher quality of life, which aligns perfectly with the idea of renewed neuroplasticity and flexibility rather than just suppression of symptoms.
Exactly. The rapid onset of benefits, often seen within 24 hours, suggests a fundamentally different restorative therapeutic response via those rapid neuroplastic mechanisms we discussed. The brain is being repaired, not just managed.
And beyond MDD, where else is this concept of temporary disruption and neuroplastic repair proving effective?
We're seeing significant promise in several areas where entrenched, rigid thought patterns dominate. Psilocybin has shown high effectiveness for anxiety and depression associated with terminal cancer diagnoses. Patients report sustained decreases in symptoms and, notably, dramatic reductions in the fear of death. It suggests a profound shift in their self-narrative and perspective. Studies are showing single sessions are superior to placebo in treating trait anxiety at 6 months.
And what about areas characterized by compulsive loops?
Yes, obsessive-compulsive disorder and addiction recovery are major focuses. In addiction, the rigid habits and reward pathways are essentially behavioral ruts.
The sledding hill again.
Exactly. The enhanced neural flexibility provided by psilocybin helps interrupt those entrenched, maladaptive behavioral patterns, allowing the patient to build new, healthier coping mechanisms in that plastic window.
This momentum means researchers need to get even more specific about the molecular step-by-step process. If we want to optimize dose, setting, and integration timing, we need a precise, minute-by-minute map of the neuronal changes.
Absolutely. The next generation of research is focused on utilizing incredibly innovative tools to capture these transient effects. One major innovation we're tracking is the CAST tool.
CAST.
It stands for CA2 plus AMPTUS activated split terboid. It was developed at UC Davis.
Okay, that acronym sounds intensely technical. Use an analogy to break down the function of this camera snapshot tool for us.
Think of previous methods of mapping activated neurons as trying to take a photograph of a sprinter using a long exposure camera. You capture where they started and where they ended, but the image is blurred. You don't see the specific muscles firing at the moment of peak exertion.
I see.
The CAS-T tool is like a high-speed flash camera.
Okay, how does that flash work on a cellular level?
It capitalizes on the fact that when neurons are highly active, say in the moments after a psychedelic binding event, they exhibit a significant surge in intracellular calcium, say K2 plus 2. This high calcium level is the biological cue, or the trigger for the flash.
And what does the tool capture?
CAST uses this high calcium cue to rapidly activate a small biomolecule called biotin that labels the proteins and processes happening only in those highly activated cells. And crucially, it accomplishes this cellular tagging in a fraction of the time required by other methods, sometimes just 10 to 30 minutes.
That speed is everything. It's allowing them to capture the fleeting moments of the neuroplastic cascade that trigger the growth factors. What's the ultimate goal once they've tagged these highly active neurons in the PFC?
The goal is to perform proteomics and transcriptomics on the tagged cells. That means identifying the entire catalog of proteins and genes that are being expressed and synthesized by the specific neurons affected by psilocybin during the peak of the acute experience.
So they can see exactly what's being built.
By comparing the content of the tagged cells in psilocybin-treated models to controls, researchers can finally fully elucidate the precise, step-by-step molecular mechanism. This moves us from hypothesis to a detailed engineering blueprint.
That engineering blueprint leads directly to the next monumental challenge, addressing the necessity of the acute hallucinogenic experience. The profound consciousness-altering trip requires intensive clinical resources. What research is aiming to achieve the fresh snow effect without the need for the mountain guide?
This is the frontier of psychoplastogen research developing non-hallucinogenic molecules that retain the powerful neuroplasticity promoting effects. The term for these is psychoplastogens.
Psychoplastogens.
One highly promising candidate is tabernanthalog, or TBG, which is an analog of the psychedelic ibogaine.
And does TBG achieve the same structural growth we saw with psilocybin?
It does. TBG promotes cortical neuroplasticity and dendritic growth by activating the same neuroplastic pathways, specifically by acting on the 5-HT2A receptor system and downstream BDNF mTOR pathways. But crucially, its structure is modified so it doesn't trigger the massive glutamate bursts typically associated with the intense psychoactive effects and the chaos of high entropy.
So we're talking about isolating the grow signal from the whiteout experience. Why is this isolation so important for the future of treatment?
Accessibility. If you can retain the sustained growth and flexibility effect without requiring a 6 to 8 hour intensely supervised subjective experience, you dramatically increase scalability.
It opens the door to a future where these treatments could potentially move out of specialty clinics.
And perhaps be administered at home if approved by regulators. This would be monumental for the estimated 1 billion people worldwide who suffer from chronic conditions potentially responsive to these compounds. The future goal is retaining the ability to stimulate dendritic growth while making the process universally scalable.
It's the difference between needing to climb a mountain to achieve self-reflection and having a simple biological tool to help you rebuild. This entire deep dive has just revealed the profound biological basis for psilocybin's therapeutic potential.
It really has.
So let's bring our journey on the sledding hill to a close. We started with the brain frozen in deep, painful ruts, the atrophy and hyperconnectivity of depression. Psilocybin provides that profound, thick coat of fresh powder snow, temporarily smoothing those rigid pathways. It uses the chemical machinery via the 5-HT2A receptor, BDNF, and the mTOR pathway to lay down brand new physical infrastructure.
But the lasting therapeutic effect, that sustained remission we see in the clinical trials, comes only from you, the skier. The flexibility is temporary. It requires actively choosing and intentionally carving a new, healthier path through dedicated therapy and integration practices during that crucial neuroplastic window.
And without that intentional work,
The structural scaffolding lacks direction, the snow melts, and the old ruts regain their dominance.
And as we close, we need to issue our most crucial disclaimer. This science, these stunning efficacy rates, 75% response, 58% remission, they're derived entirely from controlled clinical trials.
Entirely.
These settings involve professional supervision, regulated doses, and intensive therapeutic support spanning preparation and integration.
Absolutely. Self-medication carries significant risks, especially given the emotional vulnerability that is amplified by these substances. The context of care is literally as critical as the compound itself for achieving sustained positive outcomes.
Finally, a provocative thought to leave you with, connecting back to the initial complexity of the 5-HT2A receptor and the conflicted imaging results. Given how psilocybin acts so dynamically on both excitatory pyramidal neurons and inhibitory interneurons, creating this functional chaos, it raises an important question. If activity is simultaneously increasing and decreasing across the network, is measuring individual cell activity or general metabolic changes truly the best gauge of the drug's effect?
It's a great question, and probably not. The complexity highlights why researchers are increasingly measuring network oscillatory activity. Specifically, they look at things like increases in high-frequency gamma oscillations, which is the brain's highest cognitive power band.
And what does that tell them?
Increased gamma power suggests highly complex, desynchronized, and functionally diverse states. Measuring this network complexity is likely a much better method for understanding its net effect on large-scale synchronization and communication capacity knowledge that researchers are only just beginning to fully explore through modern electrophysiology.
The fungal kingdom is complex, powerful, and holding neurological breakthroughs that are truly unparalleled.
It is indeed a constant source of wonder.
Thank you for joining us for this Wonder Fungi deep dive into the architecture of the brain and the transformative power of neuroplasticity. If you found this discussion insightful, please take a moment to like and subscribe to the channel to support more deep dives into the fungal kingdom and the cutting edge of science. We'll see you next time.